So what exactly is a limit? In the world of calculus, a limit is the y value a function approaches as its input, the x value gets closer to a specific point. Imagine it as an archer, aiming for a target, getting infinitely close, but never quite hitting the bullseye. This is Zach. He's on a quest to understand exactly what is a limit. So just like you, Zach is also about to start AP Calculus, but he is clearly struggling to find his way. As Zach nears the mysterious X, we jump into the core principle of limits. Zach is coming infinitely close to a value without actually reaching it. So let's check out this graph. F of x is equal to x squared minus 4. Zach investigates what happens as x draws near 2. As the graph gets closer to the x equals 2, on both sides, we can clearly see the y value is getting closer to 0. To grasp this concept algebraically, we look at the same graph as x approaches 2. We can use the process of direct substitution, so simply plug 2 into f of x, then we will get 0. This is the process for evaluating limits when the function is defined at a point, but that is not always the case. Sometimes we have functions that are undefined where the limit exists. So let's check out this example here. Facing a sudden gap, Zach thinks about functions with undefined values. Now, he's a bit confused because direct substitution doesn't work here with this function. F of x equals x squared minus 4 over x minus 2. But when we look at a graph, we can see something very unique. If you look at this graph really closely, you can see that there's a small hole when x equals 2. Therefore, the function is undefined at that point. Now, even though our function is undefined at x equals 2, the limit will still exist. As we approach x equals 2 from the left and from the right, the y value appears to be approaching 4. So that will be our limit. It's important to note that a function doesn't have to be defined for the limit to exist. Algebraically, if we would have tried plugging in 2 for x, this would have resulted in 0 over 0, therefore highlighting that this function is undefined at x equals 2. To solve a problem like this, we would need to factor the numerator. And then after simplifying, we will be left with f of x equals x plus 2. Now, by evaluating this simplified form, as x approaches 2, we find the limit to be 4 via direct substitution. Now, here's another example to help Zach understand limits. With this graph here, f of x is equal to the absolute value of x minus 2 over x minus 2. If you look at this graph, what is happening as the limit approaches x equals 2? We can see that the limit from the left side is equal to -1, and the limit from the right side is equal to +1. In situations like this, the answer would be that the limit does not exist because the limit from the right does not equal the limit from the left. This is a requirement for the limit of a function to exist. So I know that limits can be a bit tricky, but all you have to remember is that the limit from the left side of a function must equal the limit from the right side of a function. And if that is true, then the limit will exist. Now, Zach may have reached his destination, but this is just the start of how we understand what a limit is, both graphically as well as from the algebraic perspective.